All right, this is for Math 3. This is Monday, September 13th, 2021, and an extension of what we covered in class today. I began with a debriefing about the quiz we took on Thursday, and in that debriefing, the first issue was, given two pairs of points, construct the equation of a straight line that goes through those 2 points. So this is all on the topic of linear functions. And there are 3 ways that we can express a linear function. One way is called standard form. In that form, it's some coefficient constant a times x plus some coefficient b times y is equal to some constant c. That is the standard form of a linear function, the equation of a straight line. Another way of saying the same thing would be in point slope form. In that form, it would be y minus y1 is equal to m, the slope, times, open parentheses, x minus x1, where m is the slope of that line. The slope being rise divided by run. Change in y value divided by the change in x value. The third way of expressing a line would be in slope-intercept form. That is y is equal to m, the slope, times x, plus b, which represents the y-intercept, that value of y when x is equal to 0. Now, the problem we did in class was number 1 from the quiz. But what I'm going to do right now is just randomly generate another example that, like what we did in class. And I didn't think about this ahead of time, but I'm going to use a random integer generator from -10 to a maximum of 10 with 4 values, and that will represent 2 pairs of points. Here they are. So in this example, suppose I give you the points 9, 7 and 5, -10. And I say, generate a straight line that goes through those 2 points. The first thing I would do is a little sketch to give me an idea of where these things are. So 9, 7 is 9 units to the right, 7 units up, so it's somewhere up in quadrant 1. The second random point was 5, -10. So 5 units to the right and way down there. So there's my 2 dots, and right away I can tell you by looking at them, this line is going to have a large positive slope and a very large negative y-intercept value of b. All that just by glancing at this little sketch, as you can see. Formally, I would first calculate the slope. The slope m is the rise over run, the change in y value divided by the change in x value. For the y value, it's the final value, so this is equal to -10 minus the initial value, so -7, all that divided by the final x value, which is 5, minus the initial value of x, which is 9. You have to do it in the order of final minus initial. Y final minus y initial divided by x final minus x initial. This is the final point. This is the initial point. This is the initial point. This is the final point. Always in that order. So what do we get? -10 minus 7 is -17. So the slope in this example m is minus 17 in the numerator. Down below, 5 minus 9 is negative 4. The two negative signs cancel, and the slope has a value of 17/4 as an improper fraction, or that would be 4 1/4 as a fraction in proper form. For me, the next step would be to express this in point slope form. And it doesn't matter which of the 2 points I choose to be my x1 and y1. I can choose either the initial or the final point, and they're both going to work equally well. As a demonstration of that, for point slope form, it would be y minus, and I'll choose the first point. For the first point, y initial has a value 7, so y minus 7 is equal to, and now for the slope, I'll write it as 4 1/4 times, open parentheses, x minus the initial value of x, which is 9. Note that this is the first point listed, but it's actually the upper point of the two. So, on my sketch, I labeled the left dot as the initial point and the right dot as the final point, but the order in which I wrote them was actually I wrote the final point first and then the initial point second in terms of random values. Anyways, here it is in point slope form using one of the 2 points. I could have written the same expression using the other point in point slope form. That would look like y minus negative 10, which means y plus 10 is equal to 4 1/4, open parentheses, x minus 5, close parentheses. Even though these don't look identical, they are. With a little bit of tweaking, massaging, rearranging, these work out to both be the point slope form of a straight line passing through both of these 2 given points. Okay, next, to express this in slope-intercept form, at slope-intercept form, we're finding the value of y when x is equal to 0. All right, so fair enough. Plug in x equals 0, and what do you get? For either one of these, let's do this guy as an example. So when x is equal to 0, this becomes y minus 7 is equal to 4 1/4 times 0 minus 9. So I just put minus 9 in parentheses. Solving for y, I'm going to add 7 to both sides. So y is equal to 7 plus, well, actually minus 4 1/4. I see I wrote 1/2. I was just testing you to see if you were paying attention. 4 1/4 times negative 9 is some messy value. 4 times negative 9 is negative 36. Negative 36 plus a negative 9/4 would be negative 38 1/4. So now I subtract 38 1/4 from 7, and that will give me the value of b, the y-intercept. So b, the y-intercept, is going to be negative, if I do this correctly, I suspect it's 31 1/4. So in slope-intercept form, this looks like y is equal to 4 1/4 times x minus 31 1/4, if I did that correctly. 7 minus 38. Well, I still think that's negative 31 1/4. Oh, yeah, still think so. Okay, so there it is in slope-intercept form. And of course, the last way to express this would be in standard form. To put it into standard form, I would kind of like to get rid of that fraction of 1/4, but maybe not first. So let me just subtract y from both sides, add 31 1/4 to both sides, and rewrite it. So 4 1/4 times x minus y is equal to 31 1/4. This is standard form. I'll just write STD for standard. This is point slope form. No, I'm sorry. This is slope intercept form. And both of these, whichever way you want to write it, whichever point you want to use, both of these are in point slope form. Point slope form. Ta-da! My claim is it's believable that this value of b is a very large negative number. It's my belief that that I did this correctly, and that any form of these equations will pass through both of those points. So if you really want to check, you could plug in x equals 9 and see if y is equal to 7 when you get done. Plug in x equals 5 and see if y is equal to negative 10 when you get done with this. Okay, so we did that in class today to kind of lead off. And here's something relevant. I almost feel like repeating. All of this is linear functions, which is how the class performed the best on Friday's assessment by that university. And with linear functions, we can express them in standard form, STD. We can express them in point slope form, point slope. And we can express them in slope intercept form. For the rest of this month, we're also trying to become proficient dealing with quadratic equations. And sure enough, for quadratic equations, there's 3 ways we can say the same thing. There's standard form. The standard form of a quadratic equation is y is equal to a times x squared plus b times x plus c. There's also factored form. And this is where we would say y is equal to a times open parentheses x, let's say plus root 1 times x plus root 2. And in class today, I wrote minus signs here instead of plus signs. And I'll leave it the way I'm doing it right now. And finally, there's vertex form. And that means y is equal to some constant a that cannot be equal to 0 times x minus h quantity squared plus k, where h and k are the coordinates of the vertex of this parabola. R1 and R2 are the 2 roots of this parabola, and ax squared plus bx plus c are the coefficients in standard form. We're going to be practicing this over and over this month. I gave an example in class of here's 3 points, negative 1, 1, 1, 1, 3, 9. Work out the equation of the parabola of the quadratic model that fits through those 3 points. And what I first did was a little sketch. And as soon as I sketched the first 2 dots, I established that the axis of symmetry has to be the y-axis, because when x is equal to -1, y is equal to 1. When x is equal to +1, y is equal to 1. They both have the same value of y when they're both 1 unit away from the y-axis, either left or right. So therefore, the line of symmetry, the axis of symmetry for this parabola, means the axis of symmetry is the y-axis. What I didn't know with those 2 dots is whether the parabola is opening up or down. So when I plotted the third dot, 3, 9, on my little sketch here, that settled the issue. This is an upward opening parabola, and that means the value of A is going to be greater than 0. And the value of C, the value of C is going to be the y-intercept. And now that we've done this problem and solved it completely, the new improved sketch has a value of C equals 0. It's what we established by doing this algebra. So what we did is we wrote the equation of a line in standard form, ax squared plus bx plus c. Then we plugged in the values of each set of coordinates, -1 for x and 1 for y, to create the first line. +1 for x, +1 for y to create the second line. +3 for x, +9 for y to create the third line. And we arbitrarily gave each line a letter, like E, J, and S. A student suggested that we eliminate C. You can eliminate C by subtracting any 2 equations from each other. So we did the second equation minus the first equation, and right away that gave us, oh man, what did that give us? That gave us 0 is equal to 0 plus 2 times B plus 0. So immediately we could figure out that B is equal to 0. Then we subtracted the bottom equation from the middle equation. Actually, I think we subtracted the middle equation from the bottom equation. Right. We subtracted the middle equation from the bottom equation. And that led to 8 is equal to 8a. We already know that b is equal to 0, so plus 0 plus 0, because the c's canceled out. So now we have the value of a. A is equal to 1. Plugging a is equal to 1, b is equal to 0 back into, let's say, the top equation. That shows us 1 is equal to 1 plus 0 plus c, and therefore c is equal to 0. So here's our 3 coefficients. Y is equal to 1 times x squared plus 0 times x plus 0, or y equals x squared. I'm going to do a second example, and this is all from a handout in class today called Practice 5-1. I will do number 2 as an example of the same thing. So this is Practice 5-1. This first one today was, number 1. And this second one today will be number 2. It says, find a quadratic model for these 3 points. And the points are -4, 8, the points -1, 5, and the point, really, 1, 13. First thing I would do is a little sketch to have a sense for this. So -4, 8, 4 units to the left, 8 units up. I'm going to say it's around there someplace. -1, 5. So that's going to be around here someplace. And then 1, 13 is going to be up here someplace. So it's clearly going to be an upward opening parabola. My sketches are a little too crude to be sure, but I believe the vertex will be to the left of the middle dot here. And I'm just saying that because when I go from -1 to +1, it goes from 5 to 13. If it were symmetric about the y-axis, the way this first problem was, then it would have the same value of y at 1 as it has at -1. So I'm claiming the vertex is between the first dot and the second dot. All right, let's get on with it. To solve this, we write the equation of a quadratic in standard form. Y equals a times x squared plus b times x plus c. And now we plug in the values of x and y 3 times. First time, I have 8 is equal to, now -4 squared is 16. So 16 times a minus 4 times b plus c. Second time, I'm going to plug in -1 for x and 5 for y. 5 is equal to, now -1 squared is 1. So this becomes a minus b plus c. For the third point, I'm going to plug in 1 as the value of x and 13 as the value of y. 13 is equal to, now 1 squared is still 1, a plus b plus c. I now have 3 equations, 3 unknowns. And I know that when I subtract any equation from any other equation as is, that's going to make the c's cancel. What I'm kind of fishing for is what else can I kind of figure out from this. So I'm really focused on the second and third equations because they both have 1a and they both have 1c in them. So if I subtract this second equation from this third equation, I will lose both the a's and the c's and have nothing left but b's and a constant. So I'm going to do that. The third equation minus the second equation becomes 13 minus 5, which is 8. A minus a is 0. B minus -b is plus 2b. Or not to be, that is Emmanuel's question. And c minus c is 0. So, ta-da, right away, I can establish that 8 is equal to 2b. Therefore, if I divide both sides by 2, I get b is equal to 4. I can now substitute for b into all 3 equations and keep grinding this out. So, by the way, here was the first equation. Knowing that b is equal to 4, I could write all of this as, if you want, you can plug in just that one piece of information and combine like terms, and it will simplify down to only 2 unknowns, A and C. I'm going to suggest that, what the heck, I'm going to go ahead and do that. So the first equation with b equals 4 becomes 8 is equal to 16 times a minus 4 times b. 4 is 16 plus c. Now when I add 16 to both sides, this is going to become 24 is equal to 16 times a plus c. So there's the first equation with b equals 4 inserted into it, like terms combined and simplified. The second equation would be 5 is equal to a minus 4 plus c. If I add 4 to both sides, that becomes 9 is equal to a plus c. And already I have enough information that I can eliminate a with those two expressions. But I'm going to write the third one as well. So equation 3 becomes 13 is equal to a plus 4 plus c. When I subtract 4 from both sides, that becomes 9 is equal to a plus c. You can notice now that this is redundant. This is telling me the same thing twice. I can now solve by substitution or elimination. But I really only have two equations now and two unknowns. A and C is unknown, and I've got 24 equals 16a plus c, and I've got 9 equals a plus c. Now these are both straight lines. If you were to sketch them on an AC coordinate plane, you'll find one's got one slope, one has a different slope, and there's only one point where they intersect, and that's the solution. I suggest that we solve by substituting for c. So if we take this one equation that we have and isolate the c by itself, it becomes c is equal to 9 minus a. And with my handwriting, hopefully you can tell the 9 and the a's apart. So I'm going to substitute 9 minus a for c into this remaining first equation. So this becomes 24 is equal to 16 times a plus, and now instead of writing c, I'm going to write 9 minus a. Now I have one equation and one unknown. Combine like terms and simplify. Step 1, I'm going to subtract 9 from both sides. 24 minus 9 is 15. Step 2, I'm going to combine 16a with negative a. 16a minus a is 15 times a. Last step, divide both sides by 15, and I get a is equal to 1. I have the value of b, and now I also have the value of a. The last step is to find the value of c, which will also be the y-intercept in this situation. To find the value of c, I can pick any of these equations. I will pick this small simple one here that says 9 is equal to a plus c, and plug in for a. So 9 is equal to 1 plus c. When I subtract 1 from both sides, I have 8 is equal to c. As you can see, I'm now ready to write the equation of the parabola in standard form. Y is equal to x squared, because it's ax squared and a is 1, plus 4 times x plus 8. When x is equal to 0, y is equal to 8. And that is believable. That means this point is the same y value as the first point. And that means halfway between 0 and negative 4 is the axis of symmetry. So at x equals negative 2 is where this parabola turns from going down to coming up. Is there anything here that would prove that to you? I'm going to claim later we'll see the x-coordinate of the axis of symmetry for a parabola written in standard form is given by negative b divided by 2 times a. And if I plug in negative 4 divided by 2 times 1, sure enough, the axis of symmetry is at x equals negative 2. All right. That seems to be enough for the moment of examples and modeling of how to find a quadratic model. Of course, you should do a little further checking with these results and verify that they do hit the original 3 points. So if we plug in x equals 1 into this equation, that's easy. You can do that in your head. 1 squared is 1. 4 times 1 is 1. 1 plus 4 plus 8 is 13. And that is the coordinate of this last point, 1 comma 13. If you plug in negative 1 for x, you get negative 1 squared is 1. Minus 4 is negative 3. Negative 3 plus 8 is positive 5. Sure enough, that's the coordinates of the second point, negative 1 comma 5. For the very first point, negative 4 comma 8, well, negative 4 squared is 16. 16 minus 16 is 0. 0 plus 8 is 8, and that is the coordinates of the first of the 3 points that were given. So I've just confirmed that I didn't make any mistakes this time. This concludes this supplemental video for today.